Hello everyone, welcome to Summer Internship Program. In the first video practice, we have learned with you how to set up the total station over the survey mark, and we did leveling and centering. In today's practice, we will learn how to calculate the coordinate points, and we will calculate coordinate of the points with a Bessel rule. And during this process, I will introduce mechanical part of the total stations. Today, as an example, we will calculate coordinates of these four corners of this table, because this is in a small scale, but in large scale, this could be a good example of the four corner of the building or foundation of any building structures. The first thing we have to do is to draw the sketch. I use this blackboard. So I start with a point. This is the point, is the location of the total station, and this point could be arbitrary coordinate system or a global coordinate system. If this is the arbitrary coordinate system, in practice, usually we give to 100 to 100 or 1000 to 1000, but of course this depends how large area we are working. But we are working now in a small scale, small room, so we can give this 10 meter to 10 meters. Okay, I draw the. So this is 10 to 10. I draw the graph. This is 10 meter to 10 meter. And this process is called false easting and false northing, because in practice we don't want to get the negative values. Okay, this is my y, or we can say this is the northing also, and this is the x value, and this is also could be easting. Okay, and and this is the approximately my this is the table. Okay, this is the table. So this is my rectangular table, and I have to find the coordinates of the point 1, 2, 3, and 4. But before, I have to define the my backside point or reference point, because all my horizontal angles will be referred to this reference point. So this is my reference point, you see here, reference point or backside point. I have to install here the tripod and prism. So this is my tripod. I will use the star or spider, the stable position of my tripod and prism. I release all connections and hinge. Okay. Go here and fix it back by unscrew. So I look through this tripod head to find my backside points. Now I can see the backside point through this tripod head. Okay. This is almost parallel to the backside points, and I will use this tri-back. Okay, tri-back with the circular ear bubbles, and I will install this here. Okay. The ear bubble is not centered, so I will use this tripod leg to adjust this ear bubble. Okay. Almost done. Now I adjust it, and the ear bubble is the center. So the next mechanical part of the total station is this is a carrier with the optical plumpet. Okay. Now I install this. So, in optical plumpet I3, I see through this optical plumpet, and for a fine adjustment and for finalize the centering process. For fine adjustments, I have to move this tri-back on the tripod head. Okay. Now I completed the centering. Okay, but I broke the leveling, so I level again. So I'll finish it with the leveling and centering. So here I mount the prism. Okay, this is the prism. So our reference point is ready. So now I define my reference point or backside point on this blackboard. So this is the approximate location of my reference point and reference point, and I assume that this line is parallel to the main axis, y-axis, okay, because this is to facilitate our calculations Actually, this is no problem. The backside point could locate in here, in here. Actually, this is no problem, but I want to make easy to my calculation. So I assume this is my reference line is parallel to the main axis. Okay? To find the coordinates of the point 1, 2, 3, 4, I need the two parameters. The first, bearing angle, alpha 1, okay, and D1, and alpha 2, and D2. Sorry, I have a small space. And I have alpha 3 and D3, alpha 4, and D4. This is all the polar coordinates of the point 1, 2, 3, 4. Okay. Now we have to assign our station point and reference point in the total stations. Now you can see this display, so I have to create the file. We have to set up this station, 1, set the job. So new input. Today is the 7th of July. 7th. Okay. 7th of July. Enter. Okay. We set the job at F1. Here, orientation with angles. This is okay. But here you can see HI. It means height of the instrument. That means we have to calculate. We have to measure the height of the instruments. So. Actually, the height of instrument is start from the cross section of the three axes: vertical axis, horizontal axis, and the sightline axis. Cross section of the three axes from this point until the survey mark. Okay, and here you can see in the total station. We have the symbol, the cross section, and the height of instrument is start from here until the survey mark. Actually, in practice, it's to measure from here until the survey mark. It's practically difficult. That's why we use spatial instruments, and we attach here. And this is the spatial ruler. Is used only to measure the height of the instrument. So. The tip of the ruler should be coincide with the survey mark, okay? And this distance from here to here, it will give me the height of the instrument, the distance from cross section until the survey mark. This is the spatial ruler. So now I read the height of the instrument, and this is equal to 1.559 meters. Okay. Now I insert the height of instrument in total station. Perfect. So the location of the total station is, the coordinates of the total station is 10 to 10 meters. So I have to insert this. Easting is our x values. North here is our y values. So I insert the values. This is the 10, okay. That's it. 10, 10. Okay. The height is, we use absolute or arbitrary heights. It's a datum. So in our case, we can write maybe hundreds. This is arbitrary. The only thing we have to do the set our reference point. Okay, our reference point is there. So I have to look through the eyepiece of the telescope and try to bisect the crosshairs of the telescope to the prism. When when both crosshairs is bisect and I found the right moment, and I press the set. Now I assigned our reference point. So until now I set the station points and I give the 10 to 10 coordinate points, and the elevation is 100, and I also assigned the reference point to the total station. Now I can measure the coordinates of the point 1, 2, 3, 4.